So we're looking at status bar notifications in the Android operating system, and this applies to both the tablet under Honeycomb 3. It also applies to the phones, which are commonly running on Android 2. But the basic idea is that rather than delivering a toaster message at the bottom of a Windows screen that might interfere with what we're doing, Google has a different approach to this. There's something called a status bar at the top, and we can push event notifications into that status bar at the top, put an icon there, and then let the user decide when they want to read that. So let's take a look at how we can build an application that utilizes status bar notifications. So we're in the Eclipse development environment for Java, and we're going to say File, New, Project. Here under the New Project dialog box, we're going to set up a select the wizard that knows how to ask the right questions for an Android project. And here we go. So we're looking at the Android wizard for creating a new Java application under Eclipse. And the first name is the project name, and this is something that any Microsoft Visual Studio developer would know how to answer. It's something that doesn't apply to the name of the application that gets shipped to the Android market. It only has to do with what we call this within the Java Eclipse development environment. And also, just as a footnote, if for example we had a project that we wanted to share with our developer friends, our peers, basically this project name is our folder name. It's something that we would then zip and send over and then import into another instance of the Eclipse development environment. So let's try this out. So we're going to say the project name is AppDev Android Status Bar Notifications. So AppDev Android Status Bar Notifications _ project. Remember that throughout the set of examples, we're trying to tack at the end of every object name, everything, its type, so that when we see it pop up in other places, we know where it originated. So for example, if we open up the manifest.xml file and we see things like the min SDK version, well, where did that come from? Well, that's something that gets set right here originally, but we could change it later. Or the name of the Java class file for the first form, where did that come from? Well, that comes from here. The title bar on the app when it starts and the name of the app that goes to the Android market, where did that come from? Well, that comes from here. So it's kind of at times helpful if we tack on the object type here at the end, so that when we see it pop up in other places, we know where it originated. So we're going to target API level 4 here using the Google APIs, so the Android open source Java libraries, and also things like maps from the Google corporate libraries. So application name, AppDev Android Status Bar Notifications, and then instead of project here, we're going to put the word application. Next, the package name. So we start off with the website in reverse order. So com dot, the top level domain first, then the second level, and then we'll tack on the name of the app. And we'll end this with the descriptor here, package. Also, the activity is the user interface, and typically, yes, we would like to default to letting the template create the first one. The min SDK version is 4, so when this ships out to the Android market, if we have a phone that doesn't have at least this version, it will hide itself from that phone in the catalog. So here we go. So we have AppDev Android Status Bar Notifications project. We have the folders, SRC, that's our Java. The generated folders has nothing yet. The Google API is the Android API. Is basically what this says is we have the open source Android jar, and we have the maps, the corporate stuff that has some licensing restrictions and requirements. And the resources. So under resources, we have the layout, that's our user interface, and we have the values, these are the strings, and we can make one adjustment to that. So looking at the XML view, we'll tack on the 3 asterisks, we'll save this, and let's go ahead and launch this and test it out. So for every project that we create, we also want to set up a run configuration. So what does a run configuration do? It basically takes a project written in Java and it tells Eclipse where it goes, what to do with it. So in this example, we're not building a J02EE. We're not building a web application. We're building a mobile phone application. So Eclipse needs to do something with this that relates to mobile phones. So what we'll do is create a new Android application run configuration. And let's use the same naming convention. The nomenclature that we used before was appdev Android run configuration. And so that would be pretty helpful. And also we're working on this project called status bar notifications. So the project that this relates to is the one that we just created. The target platform, this is an interesting question. We could say automatically launch the virtual device that is listed here. We created this earlier, and we could take a look at how to create different sizes and different flavors in future sections. But what a better choice would be is to choose manual and basically let the developer choose every time the runtime starts what phone that should be tested at this time. Unlike an iPad and an iPhone where we know the hardware configurations on all of them, the difference is that under Android there's so many different manufacturers of tablets and so many different manufacturers of phones that the resolutions are all different. So we can run this, and currently we have no instances on the desktop, so we'll say launch a new instance of this one. Okay, so now we have a new instance of the virtual device, and we could press the button labeled page up, and that takes away that screen off the front. So a couple of keys to keep in mind. The home key, if we hold that down, that allows us to switch between the applications. The page up key will allow us to remove that intro screen. So here's our application. It looks good, running on port 5554. Now, in the section on SMS text messaging, remember that we'll be able to send text messages to different instances of the emulator running on this desktop. And not using the telephone number, we'll use the port number, and it knows what to do with that. So we're running the level 4 Google emulator at 640 by 360 at 72 DPI, so that it looks good on a desktop. Remember that 72 DPI is a little bit low resolution in the world of tablets and cell phones, but if we use something like 240 or 160 DPI on a desktop, it'll actually fill up the whole screen. So here we go. So we have this app. We see that the application title looks good. We can see that the activity is coming in, and the 123 asterisk prove that the change that we applied to strings.xml is carrying through to this point. So let's go back into the developer environment, and let's take a look at what's next. So we have the strings.xml file open, and the next step is to work our way up to main.xml. So what we see now is the preview window for the application, and this is the interface builder that we have at this stage in the maturity of the Android development environment. And basically it reminds me of web development when the web was in its earlier years. And the basic idea is that we drag and drop objects into this preview window, a lot like we would drag and drop an object from Microsoft Front Page onto a web page. And then we would see this preview window render it as if it was in a browser, and that's kind of what we're doing here. But the raw code is actually in XML, so when we flip over to main.xml, this is like looking at the raw HTML to a website, but it's the Android markup for a mobile phone. So what we're going to do is to make a couple of changes here. The root node linear layout sets up this namespace for Android, so all these attributes are Android attributes. The text view is a child of the linear layout, so let's tab it into the file a little bit farther by one tab stop. So we have a text view, and the width is set to fill parent, which is not something that we want to use lightly. This is only when we want to maximize the object space across the full width of the screen, and we can actually change that because that's not really necessary here. So wrap content is similar to using a span tag in HTML. It only utilizes the space that it needs. Fill parent is like a div tag in HTML. It actually takes out the full width of the screen or the full width of the parent object. So we have the text view that comes in by default. And what I'd like to do is to start off by changing the background color. So up to this point, all the examples that we've worked on have a black background. And we're going to flip that over to a white background. So where would that happen? Well, the linear layout is the parent of the text view, and currently the linear layout is the only object really on the screen that hosts other objects. So what we're going to do is to set up Android background, and if we slow down a little bit, just wait for the IntelliSense, we can actually see the choices that we get here. So background is equal to, and this is not the HTML setting where, for example, under HTML we'd say red, green, and blue values. Well, there's actually a couple more. The opacity comes first. So in this example, we're setting the background to white with the opacity set to no transparency. All right, so let's stop. Let's test this, see if it looks white. And that looks good. So we're on the right track. Now, in this example, we're building a status bar notifications window or our sample application. And basically, there are 5 different things that the event notification can display. So what we'll do is we'll set up a basic user interface for each of these 5 things that we're going to display. First of all, what is the ticker tape? Kind of like a stock ticker tape message that displays once when the event fires the first time. And then also, what are all the details below inside of the drill down detail for that event? So we'll set up some text boxes here that we could type into, and then we'll set up a button that will actually send it up into the area right here at the top of the screen. So let's work our way back, and basically we may or may not need this text view when we're finished with the example, but we'll leave it there for right now. Remember that the table layout is something that we can use to arrange things. So we can drag one of those here into the app. And by default, we can see that there are 4 rows and we need 5. So let's tweak this a little bit. We'll copy paste. And each attribute gets its own line just by convention. It's not necessary. It's just like HTML. So in an XML file, we could place the attributes of properties anywhere we want, but one convention is to place them on a separate line so that this is easier to maintain. So a table layout, if we were to modify it from the Java side, we could use an ID, but we're not intending to do that. The width fill parent is probably important just because we want to have 2 columns only on the screen. Column number 1 will put a number 1 through 5 representing the 5 input parameters, and then column number 2 will put the actual edit text where we could type those values in. So this is like building a web page. We have something that's not an HTML table. It's a Android markup table layout object, and within this we see the child object as a table row. So each attribute will give its own line, and since the table row in this example is not directly accessed from the Java side, we could take that out. And the content for the table row will have 2 things. So first of all, let's borrow the text view here, copy that to the clipboard, paste that back in. So we have this table row that contains this text view, and if we nest it, it's easier to read it. So the text view lives inside the table row, and what we like to have the content be is just the number 1. And next to the text view, we need an edit text that the user can type in content into. So let's say that we don't remember that edit text is spelled E-D-I-T-T-E-X-T, or maybe we just forgot the name of the control, the user input thing. So we could go back and find it and bring it in, and I'll drop it here at the bottom. just so that it is easier to find it. So here's an edit text. So this is important that it does have an ID because the content is going to be read from the Java side. So in an HTML document, this would be an input control. We would have a JavaScript function that would do something with it programmatically. But under the mobile phone with Android OS and developing here under Eclipse, we have an edit text, and the Java code is going to pick this up and do something useful with it. So let's give this a name, something easy to work with, not too long. I'll call it ET1, edit text 1. We're going to have 5 of them. So row number 1, edit text number 1, and this is probably enough work to stop, save, and try this out, looking for bugs along the way. So let's stop, save this, launch this. And we'll have to come back and look at why we're having red in the console, but the user interface looks pretty good. So we have this 1, that's for row number 1. We have this edit text where the user can type something. And the idea is that we'll have 5 of these, and then we'll write the code that matches these up with the right bindings on the right objects and the right method calls to send this content up here to the top, which is the area that represents the status bar notifications. So let's go back into our code. So now that we have the basic template set up for the structure of a row, rather than using the template versions, we can delete each of those and replace them instead with the table row. So here we go. We'll tweak it slightly. Row number 2, edit text number 2. Let's stop, test that. That looks good. So let's go back and make a couple more changes. We'll add the 3rd row. We'll stop, we'll save that. And we'll go to the 4th and the 5th. So 1, 2, 3, 4, 5 input controls, and each of them, by default, we could make them expand to the full width of the screen. So currently, the edit text here says that it's going to fill the parent. Apparently the parent is not very wide. So if we go back to the table row, we could set the width here to say fill parent. And we'll stop and save this until we see the results. One step at a time. We'll make one change at a time until we see the results that we're looking for. So still it's not wide enough. So the table row is set to fill parent, and actually we want to go to the first row because whatever happens to the first row actually gets carried forward down to the rows below that. So edit text fill parent, table row width fill parent, and table layout width is already set to fill parent. So that looks good. So we'll save that. So we're still looking for what is the setting, what's missing, as far as why is the width of the first item here not expanding to the width of the screen. We can see that the size of the first one is affecting the size of the rows that follow, but we're still looking for what is it that's going to set the width of this to be the full screen width. So if we go back, we have the linear layout. It's set to fill parent, and that's good. We have the text view. And the width of the text view is not related to what we're working on here. The table layout is. The width is set to fill parent. The row, fill parent. And this could be wrap content. This should be maximized. And we could do that on set the same setting as well on the other rows. So we have the fill parent set on this table row, and on the next edit text, fill parent width, fill parent, that looks good. Fill parent, that looks good as well. Okay, so we're looking at the sample application and we're asking the question as to why it is that the width of the edit text does not fully expand from the left to the right margin. So as we debug this, we notice a couple of things. The linear layout is set for the width to be fill parent, and that's perfect. We have a text view, and we could also set its width to say fill parent. Let's stop, try that out. So here's that text view. It's occupying the full width, but we see that these edit texts are not. So one way that we could debug any user interface problem, especially as it relates to the size of a thing. So one way that we can debug this problem is to change the background color of each object and also its parent. So for example, if we go back, we could change the linear layout's already white, so we know that everything that's white is part of the linear layout, and we know how big that it is because the white boundary expands to the bottom and to the right. But what we don't know, for example, are things like what is the width of this text view? What is the actual area occupied by the table? So if the table was too small, that would explain why the edit text is also too small inside that table. So for example, under the text view, if we added a color, so opacities first, we'll put solid, and then we have the red, the green, and the blue attributes. So we could say something like this. We could take off the red and just leave the green and the blue, and we'll save that. So now we can see the boundaries of this box, the text view. We can see it goes all the way out to the right like a div would under HTML. So let's say that, for example, the text view was not set with fill parent, but instead it was set wrap content. So the impact of changing that setting on the layout, we can move this over a little bit. By saying that the text view has the width set to wrap content, basically changes the left piece of this, the stopping point of the object. So rather than wrapping all the way, filling all the way to the right, it's now just stopping. And this is the basic behavior of a span tag under HTML. And going out to the right would be like the behavior of a div tag. But let's go ahead and just set it back to width is equal to fill parent. Okay, so now knowing that, one trick that we could apply to find out the boundaries of the borders of objects, even though they don't have borders by default, is to change the background color of a thing, and then we could see where it goes. Okay, so now the question is, why is it that the edit text wants to be a 0-character edit text until after we type into it? And also notice that the size of the first one has an impact on the size of the other ones also. So what we're going to do is change the background of things. We'll change the background of the row, the background of the table, and let's figure out what's constraining the size here. So the table layout itself, let's set the background on that. So a solid color, and we'll put back all red. We'll take out the blue and leave the green. So this is good. We see that the actual table layout is going from the left to the right margin. So that's not what's constraining the size of this thing. We'll go back to down to the table row. We'll take out the blue. And that's good. So we see that the row itself has the permissions that it needs to be full width. So the text view itself, so there's the text view with the blue background, and we're still looking at the edit text. So basically we could see that the edit text is the constraining factor. So the width of the row looks fine, the width of the row of the table layout looks fine, the width of the linear layout looks fine, the size of the value, actually if we put some padding around that number it would look a little bit better. So let's do that. Now, the value we use here is dip, not pixels, because pixels by themselves don't really answer a good question of how many dots that we like to pad a thing with. Density and dependent pixels, on the other hand, take into account that the monitor is at 72 dpi, that the phone is at 160 dpi or even higher, 240 dpi. So dip is the preferred mobile phone way instead of the web page way of web pages are all set in pixels that are assuming the monitor is 72 dots per inch, but mobile phones are not under the same constraint. So there's a little bit better margin here. That looks nice. So let's go ahead and take all the background colors out, because although they're interesting and helpful during debugging, they're not really here intending to match color-wise. So let's take the background out here, the background out here, and just leave the white background on the linear layout. Okay, so basically we're at a similar spot where we started. We know that all things are good minus the width of the edit text. The padding looks nicer here, so let's add padding to number 2, 3, 4, and 5. And we'll try one other little trick that might help for the size of the edit text. So padding, Control-C copy, paste. And maybe it would be easier if these two lines were actually combined on the clipboard. So copy to the clipboard, paste, paste that. So let's test this, and the one thought that might fix the layout here is if we were to put, say, throw a button at the bottom of the screen and set its width to full, the width of that button might actually cause the other things to also adjust as well. So that might be one way to fix that, because we actually need a button anyway. So we'll save that. We've got the padding right, that looks better. We can go ahead and change this message right here as soon as we get the button in that says what to do with this data. Now let's say, for example, that we didn't know button was spelled B-U-T-T-O-N, and we wanted to bring in the content from the graphical layout here. The widgets here have all things that we need. I'll bring that down to the bottom. So here's the button, and we actually want it to be at the bottom below the table layout, so that's fine. We're in it up. The text could say, remember that we're sending a status bar notification, so status bar notification. It could say send, it could say a number of different things. Whatever it needs to say, you can customize that. And so the width here will say fill parent. We'll make this a big button at the bottom. And although the button will trigger JavaScript code that will then access the content of the edit text, the button itself doesn't actually need an ID, because the Java code itself doesn't need to talk to the button. It just needs to let the button talk to it. So we have a button. We see the text of the button says status bar notifications, and the width is fill parent. And my question is, what happens when this button is displayed? Does it actually fill the full width of the user interface, and what's the impact that it has on the other objects like the table layout? So let's try that out. So here's our status bar notification, and the intention is, the question is, why is it that the button is occupying the full width here of the screen, yet each of the edit texts do not? So what we're going to do is, we'll leave that for just a moment here. We'll go to other things and we'll come back to it. But the basic idea is that we're going to use 1, 2, 3, 4, 5 edit texts off the user interface to send a status bar notification. And we're going to trigger that by the button click here, status bar notification. When we click on this, we're hoping to trigger a function within Java that will read 1, 2, 3, 4, 5 parameters, that will call the right operating system functions to set up the ticker first, to populate the drop down second, and then third, so that when we click on the detail, we want it to actually go back to this screen. So for example, what if the notification was sent and a different application was currently in focus? Could we theoretically come back to this application and respond to that notification? So that's the direction that we're heading here in this example. So let's do that. Let's go ahead and set these up, 1, 2, 3, 4, 5. And we'll set these up to represent the user interface components that we need. And we'll start by, rather than setting up a label next to the field, let's actually put the label content inside of the edit text. And then we'll just overwrite it when we type. So edit text, the first one, number 1. So the ticker text, that's actually the property, the value that we're going to set. And that's the ticker text is like a stock ticker symbol that kind of scrolls from the right to the left. Well, this is a message that will scroll. It could be stock prices, in fact, but an event notification could say, you know, here are the best stock values for today, or this is what sold, or these are the current values. But the bottom line is that it uses that same idea of a ticker text that's going across the screen. And we're going to type in that message here in this edit text. Another thing that we have to give it, it wants to know other information as well. So another thing is the number that counts, that represents a thing. So let's say, for example, that we have Facebook friend requests that are attached to our application, and we're utilizing the Facebook API, and we're accessing our own core data inside the Facebook API. There's SQL statements to access the database behind Facebook. And let's say we built a mobile app that will let us know when a friend request comes through. So one question that we want to answer is, at the top of the Facebook application page, there's an icon that has the number of incoming messages, the number of notifications, and the number of friend requests. And it displays the quantity with a little red circle. And that's the red circle that we want to populate here. So how many friend requests have arrived? So we'll say, we'll get the name of that value as friend. Actually, it's not friend request. In this example, it's the number. We're looking for the number or the count. Okay, so we're looking at the second edit text, and the purpose of the second edit text is to provide a path for the user to type in the number, the quantity that's in that red circle. So the third item that we need to take a look at here is the content title. So the content title is a lot like on an email message. We have a subject line, and the content text that we'll put into that is kind of like the body of an email message. So content title, that's the number 3 question, the third item. And another question that we're going to ask is the actual content, the body of the content, and we'll call that content text. So the body of a message, the body of an HTML document, but here it's called content text. And then finally, the number that we'll use for the ID. So remember that under r.java, everything gets an ID for the purpose of the compiler in Eclipse. Well, also at runtime, that concept is applied here. So every status bar notification gets its own unique ID, and we invent it just off the top of our head. And this allows us to go back later and change the number that's in the red dot, or to change the text that's in the message after the fact. But one thing we cannot ever do is to redo the content of the ticker text, because that fires on the first moment that the notification arrives in the header bar. And once it's displayed, it's gone. It's not something that we're going to get back. We can come back and always change the title and the text as well. So we have the next option is the edit text for the ID. All right, so let's stop here. Let's save this, try it out. And that looks pretty good. So ticker text is something that we'll type in. It'll show up right here on the screen for just a moment. It actually doesn't scroll sideways. It actually, if it's multiple lines of text, you'll actually see it go from the bottom to the top. It'll just roll. It rolls up. The number is the number that actually sits inside of the red dot. The content title is something that we see when we grab and stretch this down. We'll see that show up here, as well as the content text. The ID is not something that the user will ever know about. It's something only the programmer knows about, and it's the way that we have a handle back to that status bar notification. So the ID is a value that does not display on the screen. The user doesn't know about it. It's something that only the programmer knows about, and it's a handle that lets the programmer refresh and update that value in the future after the original display of the status bar notification. So having set all this up, I think that the user interface is just about complete, and now we can work our way over to the Java side. And what we're going to do is to take this content and populate the objects that are necessary for the operating system to send the status bar notification. And earlier we looked at how the GPS functionality utilizes the operating system to do a get system service on the location service. Well, this is basically the same concept. We're going to use the operating system request to get a system service, which is the status bar notification manager. So let's go back over to the development environment. Let's look at the Project Explorer window. We've just taken a look at main.xml. This is the user interface. By now there should be a lot of stuff in the generated file ready for us to use. r.java contains r.id.12345 edit text objects, and this is our bridge from the markup language over into the Java side. So on the Java side, SRC, we're looking at this file here. It's called appdev android status bar notifications _ activity.java. So let's take a look at this file and let's add the stuff that we want to be here. To start off, let's just double check that the object handle references to the edit text objects are all working properly. And the way that we can do that is to set up mirrored objects here that on the Java side are pointers to, mirrors to what's living also on the markup side. So the edit text, for example, we want to set up the edit text, but instead of the XML side, we're adding this on the Java side. And let's just tweak this. 1, 2, 3, 4 more copies of that. So what's the definition of an edit text? We'll import that definition. Now what are these things? So for each of them, edit text 1, Java, it's going to be equal to something. We'll typecast edit text as the return value that comes back from a magic function call called this dot find view by ID, and r dot ID dot is the way that we magically go over to the other side on the markup side and grab a pointer, an integer to that object. So now we have a mirror of that object that's on the markup side. ET1 Java is basically a mirror to ET1 over on the XML side. We could tweak this. 1, 2, 3, 4. So now we have 4 mirrors. To these 5 mirrors to these 5 objects. And we want to know if they work or not. So we could log file them and put their name, followed by their value. So what is the value of a thing? If we go back to the user interface, and remember that we have the edit text here on the markup side, and what we want to do is to confirm that we have a valid pointer or a mirror of this object. So if we look at the text property of the object on the Java side, that would be helpful. We should see ID for number 5, and we could test this at runtime if we add some code like this. So in the log file, we'll look at ET1 Java dot get text, and we'll tweak this and make it work. Okay, so here we go. We'll save this, launch it. So the application just started. We see the ticker text, number, content title, content text, ID inside of the edit text. We're not clicking a button yet, but we are going to go over to the log file. And at the very bottom, we want to look at these values here. So the Java side sees that the edit text 1, 2, 3, 4, 5 have the following content: ticker text, number, content title, content text, and the ID. So that actually looks good, and we can clear this so that next time it looks less populated. So in the next step now, we can write the code that takes the content from each of these user-provided values, the edit text 1 through 5, actually creates an instance of the notification manager, and sends out the call to display something at the top of the screen. And that'll be the code that generates that sends out the request to the operating system to get the system service for the notification engine. So the first step that we're going to add in order to make the button click cause the status bar notification to trigger at the top of the screen is to set up the event binding for that button. Currently, if we look at the import statements, we can see that the on-click listener interface is not something that the code knows about yet. So we're going to implement an on-click listener. So the definition of an on-click listener, we'll bring that in. And there's a couple of choices here. We have the on-click listener coming from android.content.dialog interface, but the more generic, simple one is the on-click listener for a view, android.view.view. And the button itself is an instance of a view. Remember that a view is a user control. So as a Visual Studio developer, I might think of a user control here as a view. So now that we're implementing on-click listener, the class file here doesn't actually have the right method. So if we hover the cursor over the red squiggly, it says, do we want to add them? Yes. Add all the code that we don't know about. And here it's just one function, on-click. So let's make a couple of changes to this. We'll call this on-click view parameter capital V1, and we could take out the stub here, the commented code. So when we call this, let's send out another log entry, on-click, and we'll say begin. On-click, and then end. And this is where we're going to write the code to do something useful. And it will send out the status bar notification. But before we do that, the question is, how do we bind this on-click to the button? And depending on what version of the platform that we're relying on, we may actually have to manually do this binding. So there's an on-click attribute now that lives inside the markup language of Android, but it doesn't work on the earlier versions of the Android platform. One way that we can use that works on all versions is to simply write a couple lines of code here that will bind the button click event over to this function called onClick, or specifically back to this class which is capable of responding to the onClick listener events. So let's set up a reference to a button. We'll call it B1, and it'll be a button typecast that comes back from the magic function this dot find view by ID. Now the name of the button is actually going to be necessary. It's something that if we didn't utilize this type of event binding, if we just said button Android onClick equals function name, the button would not need an ID over on the XML side of the markup language. But now, in order to write code that will bind the click event for this object, in order to make the code functioning, able to function and execute on older platforms, this is the better way to do it. So Android ID is equal to create a new ID inside of r.java, and the name, we'll call this let's call it B1 button. So this should also show up under r.java. If we were to do a clean, nothing's here right now, so there's no generated code. Now there is generated code. B1 button. So now let's go back over to this onCreate. We can see the little red flag. It says that it knows something's missing, and we know something's missing also. So if we say find view by ID, r.id.button, now we have a handle to the button, and the definition of a button is undefined, so let's bring that in. So import button. So we have this handle to a button, and the next step is to bind the onClick event. So set onClick listener to this class. So this class, the current focus, is capable of responding to the onClick listener interface. So set onClick listener to call this class, and this class is going to have this function called onClick, and that's just a magic name called onClick that's part of the interface called onClick listener requirements. So let's stop. We'll save this. We'll hit go. And when we watch this, when we click on the button, what we want to watch is the output in the log file. So okay, so 1, 2, 3 button clicks correlate to 1, 2, 3 sets of begin and end, and that's a basic way that we can confirm that the event binding is happening properly between the button and the Java code. So onClick, onClick, onClick. That looks good. So now we want to take a look at the question of how do we actually do something useful here with this button click event, and what we'd like to do is to read the content that the user provide and to generate a status bar notification at the top of the screen. A couple of things happen when we set up a status bar notification. Some things happen when the app initializes, some things happen when the status bar notification gets sent the first time, and then something happens on each subsequent update to that status bar notification. So we have part A, part B, and part C to the process. So we're going to close this. This is a delayed reaction to one of the earlier launches to the emulator. We've already passed that anyway. So what we want to do is to set up what is it that we need to have happen when the app initializes. Almost like we need to have things that initialize with the edit text, we also need to have things that can initialize with the notification manager system. So we need a couple of things. We need what's called an intent. We'll call this I1. We also need to have a bring in the definition of intent, so we should have that now. Intent.content.android, that looks good. And we'll come back and discuss what is an intent in greater detail, but basically up to this point we need to think of an intent as something that's similar to a URL protocol, HTTP:/FTTP:. Basically what happens is that intents are like URLs to the operating system for the event handling model, and it causes different things to respond in different ways, and there's a lot to say about that. But we also want to have what's called a pending intent, and we'll call that PI1. So what's the definition of that? We'll bring that in, import, and that should give us one of those. Pending intent.app.android. Then also we need an instance of notification manager. Remember that when we look at GPS we have a notification manager. We have a location manager, but here we have a notification manager. So notification NM1, and let's bring in what the definition of this is. So a lot of things get wired together to make a simple status bar notification happen. We have an intent, we have a pending intent, we have a notification manager. So let's go ahead and set this up. So initialization process of onCreate. We've just set up the button click to come back into this class after the user clicks on that button. So the next thing is to set up the intent. So I1 for the intent is going to be equal to something. It's a new instance of an intent object, and the parameters that we're going to pass it are, first of all, get the application context. One thing that happens is that once the notification is displayed at the top of the screen, and then after the user drags and drops the notification list by dragging it down, we see the detail, we see the title and the text. But what happens is that if you click on that text, it actually goes back to the application that put it there so that it could be responded to. So this is going to help make that happen. The next parameter here, in fact, we could even put this on a separate line if we wanted to make, there's multiple parameters here that we need to keep track of. So we have this get application context. We also need to know the class itself. So it needs to know something about the data type of the class. So copy that, and that'll be our parameter for us to work with. So we have the class itself, we have the intent, that'll be good. So the next thing that we want to populate is this pending intent property, PI1 equals a new instance of, actually doesn't need that, actually there's a static method we could call pending intent. Get an activity, and again we'll reference the current context. So we'll say get application context. So it's a pointer to the runtime environment, the class, the activity itself. So we have that. The second piece on the request code, we're going to use 0. We can talk about that more later, but the standard status bar notification doesn't require a number there. Next, the intent, or the I1, and then a set of a secondary set of flags. So the 0 and the 0 basically say that we're not using some of the optional features, and that may not be spelled correctly. Okay, so context with an X. So now we've initialized I1 as an intent, we've initialized PI1 as a pending intent, and now we need a notification manager. So under GPS we would request the operating system to give us a handle to a system service for location services. But here we're getting a reference to the notification services. So notification manager nm1 is equal to, we're going to ask the system to bring back a notification manager. This is the typecast that's going to go into this, and we're going to get that from calling the system service. So get system service, and we could put the text string of the name of the service, or we could say context dot, and then this will help us remember what it is. Okay, so basically what we've done here is to initialize in the onCreate function the stuff that we need to use when all the magic happens when we click on the button. So we have these pointers that mirror the content of the markup language. We output them to the log to make sure they actually work. So we have this button event binding that basically binds together the event click event to this class, and we're using one of the options that works on all platforms. It works on the latest Honeycomb 3, and it works even back to the Droid 1. And this is not utilizing one of the new shortcuts, the onClick attribute, that we can now use under the markup language side. But at least this works on all versions, so it takes 2 lines of code instead of 1 line of code, but it works all the way back to the Droid 1 level 4 of the API. So we have this intent that's going to be used when we call the methods that populate the status bar notification. We have the pending intent and the notification manager, and in just a moment we're going to wire these together inside the onClick event to make something happen. to set up a status bar notification. So the first thing that we're going to do is to set up an instance of an object called a notification. So remember that under GPS we would have a location object and a location manager. Well, basically that's the pattern of all things under Android. So in this example we have a notification that works with a notification manager. So let's try this out. So we have notification, we'll call it N1, and the definition of a notification, we'll import that. And we'll say that this is equal to a new instance of notification. So now let's go ahead and populate these properties. For example, the icon, the graphic that we see displayed is something that we could set. And let's say that we don't want to create a graphic. If we look at the project template, and if we look under the high, the low, and the medium resolution folders, there's something here called icon.png, and this is kind of a useful thing that we can use to test placing PNG graphics anywhere, both in the user interface and also for the notification icon. Now, this icon right here is the little Android guy. He looks like this little green guy right here. This is something that lives on the markup side. Therefore, under r.java, we see a bridge reference to it under drawable. So r.drawable.icon really points to this file right here. So everything on the resources side is the markup side, the file I/O side, and the content under gen is our bridge to bring it over to the other side. So let's take a look at how that would work. If we go back over to the Java coding area here, the first thing that we can do is set the icon for N1. So N1 dot icon is equal to R. So that'll give us access to a sample icon. We could drag and drop other graphics into that folder, and then r.java would give us a name based on the file name of that thing. So now the value for the ticker text is going to be something that we've already found. Remember that the first parameter right here, so the value of the ticker text comes from et1 java dot get text, and the text thing inside of it's like a string builder thing inside of it. We want to have a read-only version copy of that, and we can actually borrow and tweak this code. So number 2 parameter is going to be coming from the integer value. So let's say that number 2, that's a number. We get the string value of that, and then we want to actually, let's back up right here. We're not setting the value of the ticker text. We're setting the value of the number. So number, remember that that's the number inside the red dot, like on a Facebook friend request or Facebook number of email messages. So it wants a number, not a string, and the way that we can convert that is by utilizing some of the built-in features like integer dot and then parse a string, and hey, here's a string coming back from the toString method. So that looks good. So we've set up 3 things that are needed for a status bar. We need an icon. We don't have to have one, but we're going to have one. We need the ticker text, so that's something that we see scroll up one time. We want to see the number that's displayed inside of that box. The next set of items that we're going to set by calling a method. So off of this notification, we're going to set the latest updates, and here we go. So the first parameter, set that up on its own line of one line per parameter. Okay, so the context, the currently running app, the current activity. The second parameter to this method, the title. Remember that we have all this stuff already going out to the logged file. So number 3, grab that. And then the text, we'll tweak this. And the intent. So this intent that it's looking for is what's called the pending intent, the PI1 in our case. So PI1 and a semicolon. Okay, so we're actually getting really close to sending out our first notification. The last thing that we need to do is to actually trigger the event, and when we do that, we're actually setting another value coming from the user interface. So this is actually text, edit text content number 3. 4, so we can see where all this stuff is going to come from. It's coming from the user interface, 1, 2, 3, 4, and then number 5. We'll give a call to the notification manager, and we're saying notify at the top of the screen the following stuff. The first thing is the numeric value for the ID. So we're going to make something up essentially, but since it's the number 5 text box, we'll grab it from the text box and we can borrow some of this complicated parsing code. From the number 5 edit text. So this is going to give an ID, just like the markup language side has IDs for all things. So button, for example, is an ID, B1 button, and we know that the r.java file here basically takes that button and gives it a number so that we can reference it internally like a pointer. Well, the same also is true here, so we need a number to reference that value. So let's bring this number 5 over. Whoops. So the next question is, what do we say? So we have an ID for a notification, and every time we refresh it, this number will help it know what ID that we're refreshing. If it doesn't exist, it's going to actually create a new status bar notification, and that one time will trigger the ticker text. So now let's go ahead and send it the notification, and that's it. So if nothing goes wrong here, when we compile and run this, we should see the button click event trigger the message begin to the log file, end to the log file, but somewhere in between that, it should do something on the status bar line. It should take the content from the edit text 1, 2, 3, 4, 5, and it should create a status bar notification just based on what we see here on the screen. So the code here inside this onClick event basically shows us the core engine of what it looks like to interact with the operating system when we need to update the status bar notifications at the top of the screen. And the code that we see here in the onCreate function is basically the code that sets everything up. It just gets it ready. And the code that we see above the onCreate represents the global variables that we need to have available and use across multiple functions. So that should work. So let's save all these files and let's run this in the emulator. The ticker text, we'll put Facebook friend request. The number is the quantity of friends that are currently sending a request, and we can start this off by just putting 1 and then come back and put 2. The content title, let's put Facebook friend request. And to take advantage of the fact that this is a sentence, it's a ticker, let's add more to it. Something like a little more verbose. You have received a new Facebook friend request. Now the text inside of the request could be the name of the new friend. And the idea is something that we invent on the fly. We could start with 0 and then just work our way up like a primary key in a Microsoft SQL Server database table. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So here we go. We have 1, 2, 3, 4, 5 parameters. We're going to pass them into the object. This may or may not work the first time. If it doesn't work the first time, we'll have something to debug. So we'll click on the button, and it did actually work the first time. So that was the ticker, and here's the number 1 in a red box behind our icon that we grabbed from the template. If we grab the status bar, if we drag it down like this, we could see Facebook friend request, Larry Page, and that looks pretty good. We can clear all messages here and try another one. So let's say that, for example, we had 2 friend requests. So on the number 2 in the red box, 2 different names. There we go. There's a little pop-up for the ticker. There's the icon. There's the number behind the red. Let's try 3. So that looks good. So we have 3 showing up there, and if we pull this down, we can see the names, 1, 2, 3 names. We can update this content at any time. The content of the ticker comes through that one time. There we go. So after we clear all the notifications, we can see that pop up again. And there we go. There's the number 3 on the red coming from here. This is the content for the ticker. If we look at the content of the detail, the title and the content show up here. Also, if we click on this, it actually relaunches the application. So this creates a very interesting conversation about the life cycle of every activity. And note that everything we just typed is gone. So it's almost like it reopened the application from scratch, not knowing anything about the serialization or the state of the previous instance of that application. And that's actually a very long conversation that we'll take a look at later when we look at the life cycle of an activity and when it's destroyed, when it's created, when it's paused, when it's restarted, and so on, like that. So that's it. We've successfully created an application that utilizes the status bar notifications under the Android operating system.